Hi everyone, welcome to Vedantu J English. I'm Diksha Ma'am, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to all of you or not. Yes, everyone. So today we are going to complete DNF block because guys, the time is very less, right? And we have to, speed it up. And with detail, I want to teach you everything. So that's why one shots at this point I will not be taking, but I'll teach everything detail, but with your syllabus completion. So don't worry about that, right? Okay. So everybody, are you ready for the class? So in the last two lectures, we discussed about the properties of DNF block. Till now, we have discussed all the properties, oxidation number, magnetic moment, electrode potential. These three properties are the most important properties and that we have discussed in the previous lecture, right? Now, some very little properties we are left with like alloys formation, interstitial compounds, complex formation, colored compounds. These four properties. After that, we are going to jump to KMnO₄ and K₂Cr₂O₇, on which they are asking so many questions in JEE 2025. They have already asked, and even from these properties like colored compounds, you will see JEE 2025 questions that are based directly on the colors of the compound, right? Okay, so don't ignore anything from this chapter. It has a very good weightage in your JEE mains and advanced as well. So I would really request you, please see every factual thing in this chapter. Take this very carefully, right? I know that this can be overload for your brain to have so many facts and remembering the colors, but why I'm teaching you at this point so that you can revise it yourself as well, right? After the class also you have to revise it yourself to have a good factual information about this particular chapter, right? Okay, so let us start this without wasting any time. And these are the students who have done their homework. We have Bhuvan, we have Shailesh, we have Shiva and Raja. Very good, very good. So I asked you to calculate the magnetic moment, right? That how you can calculate that. I'm just recapping that thing here. So we had chromium. Chromium is 24 atomic number, right? So that means it is 4s1, 3d5. That is the exceptional electronic configuration. When you take out 3 electrons, 1 electron from here and 2 from here, it will be 3d3. That is nothing but 3.9. So answer will be 3.8 or 3.9. That is D is going to be the correct answer here, right? Okay. Now let us start with the other properties, and I'm starting with catalytic properties here, right? Very good evening, right? Yes, Pranav. Okay, duration of the class, Priyanshu is asking. See, in my opinion, I think I think it should be over within 2 hours, right? But maybe 2.5 hours, can't say. That totally depends upon that how you are able to understand. If in one go you are able to understand, then definitely 2 hours. But plus and minus can happen, right? Okay, so let's talk about catalytic properties, right? The catalytic properties, if you talk about in organic chemistry as well, in all these reactions, you must have seen that in hydrogenation, we are using nickel, platinum. What are these? These are transition metals, right? So that we can say that these are used as catalyst as well, right? Vanadium oxide is a very good catalyst, right? So why they are used as, in first question is why they show catalytic properties, right? The reason is they can adopt multiple oxidation states, right? We discussed that how manganese can exist in +2, +3, +6, +7 in all these oxidation states. That's how it can show, because of the variable oxidation states, it is able to show the catalytic properties, right? Now, another question that can be asked you is, first is how they show catalytic properties. Next question they can ask you is a factual question that will be based on that this is a reaction. In this reaction, what is the catalyst that you use? For example, in Ziegler-Natta catalyst, used in polymerization of ethylene, it is used, right? In contact process, you use vanadium oxide, that is V2O5. In Haber-Bosch process, you use iron. In Haber's process, in the formation of ammonia, you use iron. In Wacker's process, right, you use PdCl2, again transition. Hydrogenation of alkene, you use PD and alkyne. Then we have in Adams catalyst for selective reduction, PT, it can be used. Catalytic converter for cleaning car exhaust fumes. Then again, platinum is used here. Oswald's process, which is used, platinum can be used. Oxidation of alcohol, copper can be used. Then there is thermal decomposition of KClO3. You have MnO₂, manganese oxide is used here. Right, Dieck's process, what is used? CuCl2 is used. So these are all the different processes in which the metal, the catalyst that is used from the transition series, that I have already summed up in front of you, right? Okay, so this is the first thing, then there is second table, and this is the third one, right? Okay, apart from this, because everything that is mentioned in your NCERT and in your previous year questions that I have mentioned here, so you don't need to go through different books. All you have to remember is this one, right? Okay, that's it. Now, this is a question of JEE 2022 that is based on catalysis, right? That is based on the catalyst that you have in your respective reaction, okay? So if you see this here, these are the catalysts and these are the processes, right? You have to match the following. So on the basis of catalyst, if they ask you, most probably they will ask you this kind of question, and that too, most probably the chances are in the form of match the following. Okay, so if I see this iron, we know that it is used in wait a minute, vegetable oil plus this. So vanadium oxide is used in pus, that is A, right? This is used here. Platinum or rubidium is used in vegetable oil to vegetable ghee, right? Then in the formation of, you have decomposition of ammonia. There you used iron here, hai na? So if you see this, here you use, it was the Oswald process, right? Then iron was here for Haber-Bosch process, right? Okay, so you can just match all of this. You will see the answers here, like A is 3, that is definitely right. C and D are not correct here. A is 3, that we can say that, okay, in contact process, you have V2O5, right? Then what we have, B is 1 or 2, that you have to select. B is 1 or 2, that is 2, right? B is 2, that I have just showed you here, right? B is 2, NH3 to NO, that is PT or RH is used here, right? So you can see NH3 to NO, so PT or RH is used here, so B is 2. So that means this is also eliminated. Then this will be the correct answer here. Where C is 1, what is C? C is Haber's process and iron is used here, right? And D is 4, where what we have vegetable oil, as I told you, nickel is used here, right? So answer is going to be B is the correct answer. This is the latest question of your JEE. And here, based on these facts, wait a minute, why A is 4? A is 4, wait a minute, guys. A is 4, A is 4. A is 4. No. A is 4. No. Contact process, you have V2O5, right? So A should be 3, not 4. Okay? A should be 3, B should be 2. So here it is not 4. The answer is B is the correct answer. Okay? A is 4. Let me just see if we are doing it correctly. A is 3rd, right? Then you have, from here you have PT. In this you have FP, and in this you have nickel. Let me see just here, right? Are we doing it correctly or not? Yes, we are doing it absolutely right. So answer will be B, not D. Okay, answer will be B. B is the correct answer. Okay, now let us move to the next property, that is complex formation, right? Now, if you talk about complex formation, now every one of you, let me know in the chat box if I talk about complex formation, right? Now in coordination chemistry, that is the next chapter that we are going to talk about in the next class. We are going to start with the next chapter, right? Now in complex formation, right, you will see nickel, platinum, chromium, cobalt, all these transition metals, right? So they have the ability to form these complexes, right? Now, transition metal ions form a large number of complex compounds due to smaller size. What is the reason? Because of their smaller size, high ionic charge, and availability of d orbital. That is the best part, that they have availability of d orbitals in which they can accept the electrons from the ligands. Because in the coordination chemistry, we are going to talk about metal and we are going to talk about ligands. Metal are electron acceptor and ligands are electron donor, right? So ligands will donate the electrons to the metal. For that, metal should have something empty here. So in this case, we have availability of d electrons, and that is the reason that they show complex formation, right? So complex compounds are those which have a metal ion linked to a number of negative ions, which are also called as ligand. These ligands, we will talk about all of this in coordination chemistry. Full chapter is based on this particular one page. Ligands, sentimental ion, different complexes. Full chapter is based on this particular thing. These are the examples that we are going to cover in the next chapter, right? Now, let's see colored compounds, right? So now, why colored compounds they form, right? So you will see beautiful colors they will show. I'll just show you here, right? So basically what they do is, like here you can see some ions are colorless, some are showing very intense color here. Some are showing very intense color here, right? And ma'am, do I need to learn all these colors? Then yes, you need to learn all these colors. I'll also show you why you need to learn all these colors. But before that, let's talk that why they are showing colors, right? Why they are forming very intense color and some ions are totally colorless, okay? So the reason is that we know that they have DD transitions, okay? So I'll just show you what exactly happens here, right? So what you have 5 orbitals, right? Right, this also we are going to study 1, 2, 3, 4, 5. So this also you are going to study in detail in the coordination chemistry, right? Now if you see this here, right, these are degenerate orbitals of d subshell, right? D subshell, you have 5 orbitals. Each orbital will have 2 electrons. Now we will study this in coordination chemistry in crystal field theory, that what happens due to some things here, what will happen, it will be splitted into two particular in different energies, right? So one will be higher in energy, one will be lower in energy, right? This will not remain degenerate. Degenerate means having the same energy. Here all of them has the same energy, but because of a theory called crystal field theory, because of ligands interaction, there are so many things behind that. For now, just remember that this will get splitted into 2 parts, right? Now what will happen here? D transition. See, if you have 1 electron here, it can have D to D transition. 2 electrons, 3 electrons can have D to D transition. And these DD transitions are the reason that they show colored compounds, right? If you have, let's say, 0 electron in this, then it will have no DD transition, no color will be there. Let's say it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 electrons here. Even in 10 electrons, can you see which electron will jump? If it will jump here, it is already occupied, so there is no space to jump, right? That's why there is no DD transition here. And that is the reason if you have D0 or you have D10, then these compounds are going to be colorless because of no DD transition. Because there is no DD transition, so these things are going to be colorless, right? So simple funda is that when they ask you which is colored, which is not colored, this is a simple question based on colored complexes, that which of the following ions is colored, which of the following ions is colorless, right? All you have to check is Is there D0 or D10? If it is there, it will be colorless. Otherwise, it will be colored, right? Because it will have DD transition. So when an electron from lower energy d orbital is excited to higher energy d orbital, the energy of excitation corresponds to frequency of light absorbed. When it will transform from this position to this position, it will absorb some energy. It will, let's say it is going, see, if it is going from lower to higher, you have to absorb some energy because higher orbital has more energy. So you need to gain that amount of energy to be there, right? Okay, if I am saying that there is a college, this is IIT, this is NIT. Okay, so for NIT, you have to have a certain rank, but for IIT, you need to have a better rank than NIT, right? So that means you need to get that energy, you need to get that rank to be into IIT, right? Same thing is here. You have lower, you have higher. So to be in the higher orbital, you need to absorb that amount of energy, which will correspond to a certain light, certain frequency. This frequency generally lies in the visible region that we have seen in electromagnetic radiations as well. So because of these DD transitions, what you have is, you have colored complexes, right? Simple. Now, there are two exceptions to it. So I'll tell you what are these two exceptions. If you talk about these two cases, we are also going to talk about in detail. If you talk about KMnO₄, right? If you talk about K₂Cr₂O₇, right? If you talk about these two things here, right? If you see this KMnO₄ is nothing but MnO₄ negative, or it is x minus 8 is equals to minus 1, that is x is equals to plus 7. Here similarly it is plus 6, it will be 2x minus 14 is equals to minus 2, so x is going to be 6, right? Okay, now if you see this here, manganese is nothing but it is 4s2 3d5. When you take out 7 electrons from here, it will be 3d0. Now ma'am, 0 electrons here, it should be colorless, right? Similarly here, chromium is nothing but it is 4s1 3d5, right? You take out 6 electrons here, it will be 3d0. Now, according to this particular definition, that the one which has 0 electrons and 10 electrons in the d orbital, they should be colorless, right? But in that case, KMnO₄ and K₂Cr₂O₇ should be colorless, right? But they show very intense colors, right? These two compounds, we are definitely going to study in detail the preparation properties, everything, right? So KMnO₄, it is because of the charge transfer. That is not in detail in your syllabus. All you have to know is that KMnO₄, K₂Cr₂O₇, they show colors due to charge transfer. It has a very beautiful purple color, right? So reason being, why? Because of the charge transfer. Now in these two cases, and there are other cases as well, in which in your syllabus you have these two cases, where because of charge transfer it is showing color, not because of DD transitions. And don't worry, we are going to see this in detail. You can see the name of the lecture is only KMnO₄ and K₂Cr₂O₇. So these two things we are going to study in detail, right? Okay. Now let's talk about the simple things like you have MnO₄. Now charge transfer spectra, LMCT, ligand to metal charge transfer, metal to ligand, metal to metal charge transfer, which is definitely not in your syllabus, right? All you have to do is that this is because of the charge transfer. They are showing KMnO₄ is showing pink due to ligand to metal charge transfer, LMCT. Then you have this particular compound in which, if you see this here, this is iron, right? This will also be having D. If you see this, this is x minus 6, this is 3, and this is 2, right? Is equals to plus 2 plus 4. Again, it is going to have Prussian blue color. If you see, this is Prussian blue only. That also we are going to discuss in coordination chemistry, right? Full detail of this particular compound is in coordination chemistry, so don't worry about that, right? They are interlinked. DNF block and coordination chemistry is interlinked with each other, right? So Prussian blue due to metal-metal charge transfer, right? These two are not showing colors because of DD transition. You can also include This particular, that is K₂Cr₂O₇, is also not showing because of colored DD transitions, right? Then along with DD transition, color may also occur because of polarization. This is also very, very important factor. Now I told you why colors are occurring. First biggest phenomena that I told you is DD transitions, right? A simple question will be based on DD transition, right? Second important thing is that there are some compounds that give colors because of the charged transfer also. Like you have Prussian blue, you have potassium permanganate, you have potassium dichromate. They also show color because of charge transfer, not because of DD transition. Third phenomena because of which color can be shown is because of polarization. That is AgBr, AgI are colored due to polarization, not due to DD transitions. Okay, they show color because of polarization, not due to DD transitions are not there, right? Okay, so that is the final case here. Now polarization and charge transfer are the separate exceptions due to which they show the colors, but in general they show color because of DD transition only, right? So now if you see this this particular table, please don't skip it, because in JEE 2025 they have asked question based on this one, right? So you should know the colors as well. See, it's very easy that, okay, why scandium 3 positive is colorless because of D0. Why titanium 4 positive is colorless because of D0. Titanium 3 positive is colored because of D1. 4 positive is colored because of D1. 3 positive is colored because of D2. 2 positive is colored because of D3. And this is 3 positive is colored because of D3. Right? Okay. Now all these are colored. But to remember the colors as well. Right? So for example, a titanium 3 positive is purple in color. Vanadium 4 positive is blue in color, right? Then you talk about vanadium 3 positive is green in color. Very, very important. And based on this, they have asked one question. This is your JEE 2025 question, right? They have mixed two phenomena here. One is enthalpy of atomization and then color, and they made a new question out of it, right? Which mostly students got wrong, right? So that's why I'm saying that they are asking questions like this even in JEE mains, right? Okay, it's a competitive level exam, so you can expect these kind of questions, right? Vanadium 2 positive is violet in color. Chromium 3 positive is violet in color. Then you have chromium 2 positive is blue in color. Manganese 2 positive pink. Then iron 2 positive yellow, iron 3 positive yellow, and iron 2 positive is green. Iron 3 positive is yellow in color. Cobalt in both 2 positive or 3 positive is bluish pink. Nickel is green, copper is blue, then zinc is colorless. Colorless, so it's simple, right? There is no electron, that's why it is colorless. But the colors also you should remember, right? Now I'll tell you why you should remember the colors, right? One by one, we are going to see some questions based on this, right? So if you see this here, JEE Mains 2000, this is in one set. In another set also, they have asked the same question based on the colors, right? So if you see JEE Mains 2025 question, this is the correct set of ions with the same color from the following is. Now they are saying the same color from the following. Now can you see over here you have vanadium, chromium, manganese, titanium 4 positive, vanadium 4 positive, then manganese. Out of this you should know this full chart should be on your tips. They are not even saying which color. They are saying which of the following has same color, right? So I would consider this as a tough question, right? Not an easy one, because here if you have factual information is good in your head, then it's good. But otherwise, I would consider it as a good question for your JEE 2025, right? We can expect the similar kind of questions in JEE 2026 as well. So see this, like you have vanadium 2 positive, manganese 3 positive. If you see this here, vanadium 2 positive, wait a minute, yes. Vanadium 2 positive, violet, right? Then you have chromium 3 positive is also violet in color, right? Then you have, wait a minute, what else is violet in color? Vanadium, and you have chromium, then manganese 3 positive. Let me just see that. Here it is not written, manganese 3 positive is not written here, but no worries. but it is given in the exam, right? Okay. So answer will be first is the correct answer, right? For this, what I would advise you, take a notebook and pen, write down the colors and the ions, right? That's how you can learn this. Okay, write down the colors. Okay, write down the ions and the colors, right? That's what you need to write. Okay, some ions with the specific colors, you have to write it as a group, right? So that you can remember this for your exam. If you want me to do that, I'll do that for you, right? Okay, but please remember this. It's very, very, very important for you. I'll also message you in on the Telegram channel of our Vedantu official JEE Telegram channel, right? I'll definitely message you there regarding this, right? Okay, now let's talk about interstitial compounds, right? Okay, interstitial compounds are the transition metal. In fact, before going into interstitial compound, let me just show you one very, very interesting question of your JEE 2025 based on the color, right? Okay, yes. Now, if you see this here, 3 questions they have asked. The first transition series, metal M, has highest enthalpy of atomization. Now, firstly, you should know which has highest enthalpy of atomization, right? This I told you that this particular table is very important for you for your JEE preparation, right? This is enthalpy of atomization. It is not written in the theory lines, right? When we talk about that, you have to read NCERT, you have to read the tables as well there, right? So if you see, the maximum value here is vanadium, which has maximum value, and you should also know the minimum value, right? Minimum value is for zinc, right? So maximum value is for vanadium. That means this is clear to us that they are talking about vanadium here, right? This metal is nothing but they are talking about vanadium, right? In its series, one of its equated ions, we don't know which they are talking about, exists in green color. Now, if you see, who will tell us which ion exists in green color? This particular table is going to tell you that vanadium 3 positive, I showed you there, JEE 2025 question, that exists in green color, right? Now, 2 concepts already there. Now, let us see where this question is going. That means they are talking about vanadium 3 positive, right? The nature of the oxide formed by the above, right? So now you have vanadium 3 positive, you have O2 negative. Now, even if you are here, even now you need to tell us that which oxide is this? Is this amphoteric? Is this neutral? Is this acidic? Is this basic? What kind of oxide this is, right? So can you see 3 questions, JEE Mains 2025, right? 3 questions they have asked in 1 question, right? You need to know enthalpy of atomization, which most of the students were totally blank on, right? Because table they have just read the NCERT, they have not gone through the table in detail, right? Then you need to see the colors as well. In colors, they have asked 2 questions in 2 different sets, right? So color automatically becomes important for you, right? Then this is simple, that you have vanadium oxide, which is classified as a basic oxide. Third information that you need to know is about the kind of oxides that they have, right? Okay, yes everybody, let me know in the chat box, right? Okay, so I'll just write down all the different oxides here, right, that they can ask you from here, right? So let me just write down KMnO₂ then we have CrO3. So I have written it for you so that you don't, you don't do mistakes in the exam. These are acidic oxides. Okay? Colors I have told you from where to remember. Enthalpy of atomization I have told you where to remember. Then this is about like CrO and V2O3. These are basic oxides. These are the basic oxides. Now let me write one amphoteric oxide, that is Cr2O3 is an amphoteric oxide. Now this plays a very, very important role in your preparation, right? Okay. So don't ignore any topic from this particular chapter. Do everything in detail, right? because different facts, these kind of questions they ask you. If you know the fact, then it will hardly take you some seconds to answer, right? Okay, so proof is here that why you need to do this, right? Now let's understand now alloy formation and interstitial compounds. I'm just teaching you, but I don't think so that questions will be asked from here, but yes, just go through them, right? The transition metals form a large number of interstitial compounds. What are interstitial compounds? So when you talk about the structure of any element, right? The atoms, how they are linked with each other, there are voids here in between, okay? In between you have voids. So in those voids, some other atoms can be fixed here, right? So when you fix in these voids, when you fix some non-metals here, some metals here, that is called as interstitial compound, right? So what is happening here? The transition metal from a large number of interstitial compound in which small atoms such as hydrogen, carbon, boron, very small atoms we can fix because the voids are very small, right? Occupy the empty spaces in their lattices, right? They are non-stoichiometric material, and the bonds present in them are either typically ionic or covalent, right? Like these are the examples. Like here you have hydrogen. Can you see this is in fraction? This is in fraction. These are not in fraction, but mostly they are non-stoichiometric, means they are in fraction, right? Maybe it's not properly how much atoms will be there in the interstitial site, right? So these are some of the examples. Then if you see, they are very hard. These are the properties: hard and rigid. Steel, which is an interstitial compound of iron, and carbon is quite hard. Similarly, some borides are as hard as diamonds, right? Okay, this you will see also, right? They have high melting points which are higher than those of pure metals. Now, why interstitial compounds are made? Because of these properties that they carry. Now, how they can ask you question from here, right? Which of the following is not a property of interstitial compound? This way they can ask you the question, okay? For that, statement based question can be asked to you maximum, right? So they show conductivity like that of pure metal. They acquire chemical inertness. These are the reasons that we make interstitial compounds, right? Similarly, we have alloys formation. Alloys is when we melt different metals of transition metal. Then we bind it together to form homogeneous mixture of different metals, right? So alloys are homogeneous solids of two or more metals obtained by melting the compound, then cooling the compound, right? They are formed by metals. These transition metals also, let's say you have copper, you have iron, you will melt them, you will mix them, you will have a mold, then you will cool it, and you will have the formation of an alloy, right? So now why it is very important line. What are the two which of the following can actually form alloys, right? What is the condition for alloy formation? So if you want alloy formation, then the difference in the radii should be less than 15%, right? So if it is not more than 15%, only then they can form the alloys, because they can exchange the atoms with each other and can be perfectly fit for the alloy formation, right? Okay, so let's see, here you have this atom. This is the same thing, right? If you have, when you melt it, you want it to change it to something like this, okay? This is big, this is big. Now, if this is very small, the difference is very small. Now, they won't be able to mix and make the alloys, right? So, difference should not be more than 15%. This much difference still can work, right? So, difference in the radii cannot be more than 15%, right? So that they can easily take up positions in the crystal lattice of the other. The high ionic charges and availability of d electron facilitate the alloy formation, right? So these are the properties. This you can see that this is, let's say, metal M, this is metal M dash. Now M dash has to fit and exchange the positions with the metal M, right? For that, the radii should be correspondingly like equal to each other, which is there in D transition metal, or you can say D block elements, right? Now, the most commonly used alloys are ferrous alloys that we see in daily life, right? The metals chromium, vanadium, molybdenum, tungsten, manganese are used in the formation of steel and stainless steel that we use in our houses. Some alloys of transition metals with non-transition metal are also very common, right? For example, you have brass with copper and zinc, bronze with copper and tin. So these are some of the examples that you must have seen already, right? Okay. Now let us see this. This we have done. Let us see this question, JEE Main 2024 question. That is, which of the following statements are correct about zinc, cadmium and mercury? So that's a statement based question, as you can see this here. Right? Thank you, thank you, thank you. So now, Pratap, tell me what you're not able to understand so that I can bring some light there. Hanji. So if you see this, they exhibit high enthalpy of atomization as the D subshell is full. Enthalpy of atomization is high. Can you see? I think they are after enthalpy of atomization. You should definitely know which is maximum, which is minimum. The pattern you can observe, right? So JEE 2025, they have asked one question on enthalpy of atomization. Here they have asked, and we have discussed that enthalpy of atomization is minimum for zinc, right? So this statement is definitely wrong, right? Zinc and cadmium do not show variable oxidation state while Hg shows plus. Yes, this exists in mercuric and mercurous. Right? This is mercurous, this is mercuric, right? Zinc and cadmium, they don't show variable oxidation state. That is also true, right? So that is true. Compounds of zinc, cadmium, mercury are paramagnetic in nature. Paramagnetic means they have unpaired electrons. No, we can see that they will not have unpaired electrons. Zinc 2 positive, zinc is already 3d10, similar for cadmium and mercury, right? They lie in the same group, right? So that's why they will have d10. So that's why they will not be paramagnetic, they will be diamagnetic. So this is wrong. Zinc, cadmium, mercury are called soft metal. Yes. They are also called transition metals. They are also called soft metals. So answer is B and D is the correct answer. B and D is the correct statement here. Right? Okay. Now, let's discuss potassium permanganate, potassium dichromate. Guys, okay, we have already discussed the properties of DNF block. With the proof, with latest trend, I have shown you that how they are asking the questions in JEE 2024, JEE 2025. What are the things that you need to focus on? Oxidation, enthalpy of atomization, colors of the complexes, acidity, basicity of the complexes. Magnetic moment is very simple question, okay, that they used to ask earlier. Now also they ask this question, but if they ask you magnetic moment, I would consider it on the easier side. But if they ask you color of the compounds, that I will consider it on the difficult side. So that is what you need to focus on. Right? Okay, guys, do let me know. Shall I start with potassium permanganate or not? Right? Okay. So this will be full facts and reactions, and this is highly important for you. I'll show you with the examples that how they are asking you the questions. Okay. Yes, everybody, where's the energy? How's the Josh? Everybody in the chat box, right? Okay. So let's see this here, right? Potassium permanganate, its preparation, right? If you see the preparation of potassium permanganate, what you will see, it is prepared from an ore that is pyrolusite ore, okay? Pyrolusite ore, which is actually black brown in color, which is actually black brown in the color, right? So its initial stage is KMnO₂, that is pyrolusite ore, with an alkali metal hydroxide that can be KOH, NaOH, right? Alkali metal hydroxide, and an oxidizing agent, right? Like you have KMnO₃ or atmospheric oxygen you can use. You need to use one oxidizing agent here, right? The reaction produces dark green color. Now you have dark green color of manganate. Okay. So there are two things. One is manganate, one is permanganate. Right. So I'll just write it somewhere if we have. the page. So if you talk about manganate, manganate is nothing but it is MnO4 2 negative, right? Permanganate is nothing but it is MnO4, right? This is manganate. This is very important for you, right? If you see, this is actually green in color. This is green in color, and this is purple in color. You can see it is purple in color. This you must have seen in your house also. Potassium permanganate is a very common salt, right? So manganate and permanganate is what you have here, right? It is in green in color, it is purple in color, right? Now next thing is, what is the story behind this? The story is going to remain very simple. The story behind it is going to be, firstly we are going to convert, right? What is the preparation? Okay, so I'm just writing in the form of cycle here, right? So firstly, MnO₂, that is the pyrolusite ore, that will be converted to manganate. From black brownish, it will be converted to manganate, that is green in color, right? That is K₂MnO₄, right? After this, there are various ways of converting it into permanganate, that is KMnO₄. Okay, understood? So that is the full way that we are going to discuss, right? Now if you see this, for this particular thing here, the first step is to convert the pyrolusite ore to manganate, right? Now I'll just write the colors also here. This is black brown. Okay, this is black brown ore. This is converted to green color of, rather than doing this, what I would do here is black brown. I'll write it like this, black brown. Okay, blackish brown it is. And this this manganate is actually green in color, right? So now we will discuss various ways of converting manganate to permanganate. But before that, you need to understand one thing. When you want to convert this to this, like you have MnO₂ to manganate, that is KMnO₄, K₂MnO₄, right? What is the thing that you are using? You are using one basic oxide, basic hydroxide, okay? Then you are using one oxidizing agent. It can be KNO3, it can be any atmospheric oxygen, anything, but you need to use an oxidizing agent. And this is the general reaction that you are going to do, right? Okay, it can be written in the same way, the same reactions, okay? So now, second step, to convert manganate to permanganate, we have various ways, okay? So let's understand one by one. First way is in the presence of acid, right? You can say in the acidic medium. So in the acidic medium, what is going to happen? This MnO₄ 2 negative, that is manganate, right? You can just write it here, which is green in color. This is manganate. Why I am writing it again and again? So that this gets into your head that MnO₄ 2 negative is manganate, which is green in color. In the acidic condition, it is decomposed into permanganate, which is purple in color, right? Permanganate that we have, and MnO₂, right? So this is the full-fledged thing that we have. We started from MnO₂ ore. After that, we converted it into manganate. After that, we decomposed it in the presence of an acid, and it is converted to potassium or you can say simply permanganate and MnO₂, right? So MnO₂ is stable only in strongly alkaline medium. It is not at all stable in the acidic medium. In acidic or neutral or very basic, very weakly basic medium, it disproportionate into KMnO₄ and MnO₂. This is a very, very, very important reaction. Okay. Then second way, this was the first way of converting manganate to permanganate. Second way is electrolytic decomposition. Okay, so here what we will do here, this is manganate, right? This is permanganate. The first step is same, that pyrolusite ore that is fused with KOH and oxidized using an oxidizing agent, that is same. Second step is manganate to permanganate conversion on the basis of electricity, that is electrolytic oxidation in alkaline solution. Here it is directly converted to MnO4 negative, right? So alkaline oxidative fusion of MnO2 followed by electrolytic. This is the second step that I am discussing. Okay, this thing, the second step that I am discussing here, where it is directly converted to MnO4, right? To make it better, what I can do is just ignore this part. Okay, that is the first step that we have already discussed. Okay, ignore this part as well, right? Because that we have already discussed. Just remember that second step is can also be done with the help of electrolytic oxidation, right? Third is in the lab preparation, how you will do it. In the lab, before that, there is also one more way of doing this. There is also one more way of converting this. I'll just tell you how, right? I'll just show you. In the presence of directly also if you have, there is one more way, okay? That there is one more way. If directly you use any oxidizing agent, like you have Cl2 or simply O2, okay? If directly you use Cl2 or simply O2, this is directly converted to MnO4 negative, plus you will have KCl if you have used this, you will have HCl if you use this. No, not HCl. You will have KOH, right? Okay, accordingly you will have it, right? Okay, everybody. Chalo. Is that clear? Is that clear? Yes. Now, let me just show you one more thing. Yes, here it will be O3 and this will be O2. Now, there is one more thing, right? That they can ask you that in the electrolytic decomposition, electrolytic oxidation, at anode, you will have the formation of MnO4 negative, right? Okay. And at cathode, what you will have is H2. Okay, this is also important. This also they can ask you. At cathode, you will have H2 and at anode, you will have MnO4. So till now, what we have discussed that firstly, you will have this ore MnO2. Firstly, it will be converted to manganate. That is the same process in every other cases. But to convert manganate to permanganate, we have three ways. First is in the acidic conditions, it will be decomposed to MnO4 negative and MnO2. Then second is in the electrolytic oxidation, where at anode you will have the formation of the permanganate ion. And third is in the presence of any good oxidizing agent like Cl2 and O3, you will have the formation of MnO4 negative, that is permanganate ion. Now, next is directly. Now, those three cases from pyrolusite ore I have already discussed. Now, in the lab, it is also prepared by, you have Mn2 positive. Directly, this is a very important reaction mentioned in your NCERT. Right? Very, very important reaction. Usually, we skip all these reactions, but they are very important. You have Mn2 positive, right? Here you have S2O82 negative, right? Basically, what happens here, I'll just tell you what happens here. This is S, this is a peroxide linkage, what you have here. 1, 2, 3, 4, 5, 6. Wait a minute. 1, 2, 3, 4, 5. And this. And here you have this double bond O and double bond O. Right? Okay. Yes, everybody. Now, this is actually peroxo disulfate, right? Where you have peroxo linkage. That is this particular linkage. Because of this linkage here, it is acting as a very good oxidizing agent, which is converting this +2 to +7 directly. So, directly Mn2 positive is converted to permanganate ion oxidation is happening here. You can see oxidation is happening here in this case because of this peroxide linkage here. It is acting as a very good oxidizing agent, right? Okay, that is the lab preparation. Directly they can ask you, convert Mn2 positive to permanganate. What will be used? This will be the answer. Okay, direct reaction based question. Now, manganate is paramagnetic and permanganate is diamagnetic. So now this is also a very important, interesting question and easy one. Okay, if you say manganate, that is KMn, K₂MnO₄. This is KMnO₄, right? So this is nothing but this will be +7 +6 oxidation state. Here it will be +7 oxidation state. You can calculate it as well, right? Simple calculation will be 2 + x minus 8 is equals to 0. So it will be x is equals to +6. This will be 1 + x + 8 minus 8. Minus 8 equals to 0. So x will be equals to +7, right? Now if you see this here, manganese is nothing but it is 4s2 3d5. Okay, here also you can write the same thing, that is 4s2 3d5. Now when you take out 6 electrons here, right, what will be there? You will be left with 3d1. And when you take out 7 electrons here, you will be left with 3d0, which is having no electrons. And when there are 0 electrons, that is nothing but it defines it is diamagnetic in nature. But guys, this is color. This has a color because of charge transfer, right? And here this is paramagnetic in nature because it has one unpaired electron. Okay, so that is the reason diamagnetic and paramagnetic character. Okay, yes, everybody. Hello, 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 guys. Hello, hello, Krishna. Hello, Adarsh. Yes. Hello, Prem. Okay, good, cool. Shall we move ahead? Now, if you talk about, now they are saying that manganate and permanganate ions are tetrahedral. The pi bond is p pi d pi bonding. Now, this is important, right? Why p pi? See, I'll tell you why p pi d pi bonding here, right? First, you need to draw the structure, right? Let's say this is, I am drawing for manganate, that is MnO4 2 negative. This is MnO4 negative, right? These are the two ions that you have here. So manganate, Mn, both of them have tetrahedral structure. Okay. So what I'll do here now, better will be if I write it in the way in which their colors are. Okay. This is MnO4 negative. Okay. So I'll draw it with the green pen because it has a green color, not like this green, it has a dark green color. Okay. So tetrahedral shape, so it will be 1, 2, 3, and 1 will be O negative. No, there are 2 O negatives. So what I'll do here, it will be, you can also write it like this, O, this is O negative, this is O negative, a tetrahedral shape will be there. Right? Now here you have a pink color, right? This is Mn, this is double bond O, double bond O, double bond O, and 1 O negative. That is your, which permanganate ion, right? Purple in color, dark green in color, right? Okay. Now if you see, both of them are tetrahedral in shape. Now here we are saying that they have p pi d pi bond, right? How they have p pi d pi bond? This manganese, because of this it will be d pi, because of this oxygen it will be p pi, so it will be d pi p pi bond, right? That is the reason it is having d pi p pi bonding, d pi p pi bonding, right? Okay, now let's talk about the colors and properties here, right? 2-3 properties specially related to reactions are highly important for you, right? So firstly, it is having dark purple, almost black crystals, right? So crystals are, if you can see here, they are a dark purple crystals. I don't know if how many of you have seen this at your home. This is a very basic thing in like house, right? My house, it's always there, right? So it is a very good for, bacteria killing. It is very good for that, right? So that's why, like, there was once upon a time when I was a kid, right? So I had stitches. So that was the reason doctor advised me, right? That you, when you take bath, you should always put potassium permanganate there. right? Just one crystal will give so dark color, right? But it will be, when it is in the aqueous solution, it will give you purplish color. First, it will be very dark purple, right? Then eventually, as you dilute it, it is going to lighten up the color, right? So it has dark color, purple color crystals. Then very important question, that is, crystals are isostructural with KClO3. Very, very, very important. The lattice structure is same as KClO4, right? This is very important. This is the line of your NCRT, so they can directly ask you this, right? Okay, because they have compared it here, right? That's how they are similar here, that you have KClO. In the similar way you have this, right? Okay, then we have properties not very soluble in water, right? In water they are not very soluble, right? When heated, very, very important. Now this particular reaction is very important. So I'm telling you what is important and what is not that important. So from the properties from this particular thing, right? Okay, they can ask you the, so Priya, it is not actually in this particular chapter. I'll tell you about d pi p pi bonding. This is more in detail in chemical bonding, right? So we'll discuss that in chemical bonding, right? Now I just told you an overview that why it is d pi p pi bonding, because manganese has d orbitals and oxygen, we know that that has p orbital. Even if you see, if you want to see the shortcut in detail, I'll tell you in chemical bonding. But one thing you should know is 4s2 and this is 3d5. This is for manganese. And for oxygen, what you have is this is 1s2, 2s2, 2p4, 4, 5, 6, 7, 8, right? Now, because of this, it has p pi. Because of this, it has d pi. That's why it has p pi d pi bonding. Okay, this is what you can understand for now, right? Now, let's understand this thing that KMnO₄, right? That is potassium permanganate ion. When you heat it, or even in sunlight, it is directly decomposed into manganate, that is K2MnO4 and MnO2. Now guys, do you remember that thing I told you, that manganate will be in the acidic condition? That's why it is so important, okay? In the acidic condition, it is converted to permanganate and MnO2. And permanganate, when you heat it, it is converted to manganate plus MnO2 plus O2. This is very, 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 very important, right? Okay, right, everybody? So that is very important, highly important for you, both the reaction, the conversion, the decomposition of manganate and decomposition of permanganate. So I have also written it to conclude that part in front of you, right? Okay, okay. Now let's see this here. Why do we keep KMnO4 in dark bottles? This question they can ask you. If you see in labs, KMnO4 is kept in a dark bottle. Why it is so? Because when light strikes on it, it will absorb the energy of the light, and after absorption, it will be decomposed to manganate and MnO2 and O2. That is the reason it is not kept under sunlight, because it decomposes, right? Okay. Now let's see JEE 2024 question based on this. KMnO4 decomposes on heating at this to form O2 along with which of the following, right? Now, simple direct question. This is your PYQ, right, that I am telling you. You can see this here, how based on these reactions they are asking you the questions, okay? So, KMnO4 permanganate to manganate and MnO2, manganate and MnO2, right? So MnO2 will be there, right? So this is eliminated, this is eliminated, and you have manganate, that is K2MnO4. K2MnO4 is here, and the answer will be C is the correct answer. See, direct questions. That's why that's the beauty of inorganic chemistry, that if you know the facts, if you have done enough hard work, right? If you know the facts, if you know the reactions, It will actually save your times for difficult questions of mathematics and physics, right? Even physical, chemistry, numerical, they are going to take time, but this is not at all going to take time, right? So that's why in organic chemistry, you can easily fetch marks out of it, right? So understand the beauty of inorganic chemistry, right? So next is, why do we, now this is a conceptual question, let's understand this, right? In titrations, right, what we do is we use concentrated H2SO4, not concentrated HCl. Now, statement-based question can be asked here based on this. Why we use concentrated H2SO4 when we use titrations of potassium permanganate? You will see anywhere in your titration, they will never say that use concentrated HCl. Why? Both are acids, both are strong acids. Now, why concentrated H2SO4 is used instead of concentrated HCl? Reason is that when you have concentrated H2SO4, that is directly converted to Mn2O4, which is very explosive in nature. And this, if you can see, try it yourself. This is +7 oxidation state. Can you see this? 2x minus 14 is equals to 0. So x is equals to +7. So here also the oxidation state is +7. There is no change in oxidation state of Mn. That means Mn is not undergoing redox reactions. Not redox reaction. But if you talk about in concentrated HCl, it will, this is +7. This will be converted directly to, can you see that this will be directly converted to +2, which is itself getting reduced. So this concentrated HCl is actually acting as a reducing agent, which is reducing this, right? And here if you see, here Cl is -1 and here it is 0. So here this is undergoing oxidation. This is undergoing reduction. So this is a redox reaction. So that means when you put KMnO₄ in presence of concentrated HCl, it will undergo redox reactions. It itself will get reduced. It will oxidize concentrated HCl. And that is the reason, right? We don't use concentrated HCl because that will get wasted. KMnO₄ is going to react and it is going to waste concentrated HCl. But with concentrated H2SO4, it is not going to do the same thing. In fact, if it is converted, it is going to give explosive nature of Mn2O7. That is the reason concentrated H2SO4 is used, because the reaction is not there. And here you have the reaction, which is the redox reactions, and that's why we use concentrated H2SO4, not KCl. Okay, got it, everybody? Now, next let's talk about very important statement, that is potassium permanganate is an important oxidizing agent in acidic, neutral and alkaline medium. Now, simple thing you should know is KMnO₄ in acidic medium, then you have in neutral medium, then you have in the basic medium. It is a very good oxidizing agent. We know that KMnO₄ is an extremely good oxidizing agent, right? Here also it is acting as a good oxidizing agent. It is acting as an oxidizing agent, right? So what you need to understand is KMnO₄ in acidic, neutral and basic medium, it is converted to different oxidation states. Okay? It is converted to different oxidation states. If you see, in acidic medium, it is converted to +4. Then add 2 here, it is converted to +4. Then add 2 here, it is converted to +6. Okay? So it is +2 +4 +6. +2 +4 +6 +2 +4 +6. That is how it is done. If you have acidic medium KMnO₄, which is in +7 oxidation state, it is converted to +2. In neutral, it is converted to +4. And in basic, it is converted to +6. Okay? Right, everybody? Right? Got it or not? Yes, students? Let me know in the chat box. Now, if they ask you the rate of oxidizing nature is maximum where, right? So maximum oxidizing nature is shows from acidic, then goes to neutral, then for basic. So maximum, it will show its power of oxidizing agent will be maximum. Its oxidizing power will be maximum in acidic medium. Power of oxidizing power, you can say. Oxidizing power. Oxidizing power. It is maximum in acidic, then neutral, then you have basic. Right? Okay? Yes. Now, let's see in acidic medium, as I told you, this will be converted to Mn2 positive. Ma'am, do I need to learn all these reactions? Guys, don't worry. I'm going to teach you redox reactions, right? All this balancing we will do there. For at this point, you don't have to remember any of this. You don't have to remember any of this. You don't have to remember any of this. It simply means that this reaction is very easily done, right? Its E0 potential is positive. What do you mean by that? That simply means that it is easily converted to MnO4 negative to Mn2 positive, right? It's very high. If you see this here, right, it will be, wait a minute, if you see this here, it will be low because in alkaline medium it is decreased, right? And if you see this here in the neutral medium, can you see this thing here? Let me just show you that, right? Let me just do this thing here. If you can see here, it is 1.69. Here it is 0.56. And in acidic medium, it is 1.52. So accordingly, it has its E0 values, right? Okay. Now, all you have to do is in acidic medium, it is directly converted to Mn2 positive. Now, in acidic medium, it will oxidize everything that is there. Whosoever will come, it will oxidize it, right? But the beauty is that in acidic medium, I negative, this is the exception, I negative is oxidized to I2, right? But in alkaline medium, it will be different, okay? That will be different, okay? For now, because Fe2 positive will always be oxidized to Fe3 positive, that is not a big deal, right? Easily it can oxidize, right? Then C2O4 2 negative oxalate ion is converted to carbon dioxide here, right? Directly you can see. Hydrogen sulfide, that is S2 negative, is directly converted to sulfide from -2 to 0. Okay, directly you can see that. Sulfuric acid, that is SO3 2 negative, is directly converted to SO4 2 negative, increasing the oxidation number. Right? NO2 negative is directly converted to NO3 negative. As you can see this here, again, this is x minus 4 is equals to -1. So it will be 3 here, right? And here it will be x minus 6 is equals to -1. That will be 5 here. So you can see oxidation number, it is always increasing, right? So it is acting as a very good oxidizing agent. If you see in the neutral medium, it is converted to, can you see this is a +4 oxidation state that I directly told you that here this is getting converted to Mn2 positive. Here it is getting converted to Mn4 positive in the form of MnO4 2 negative, right? Wait a minute. Yes. MnO4 2 negative, right? Now, this is in the MnO2. Yes, I'm so sorry. Then so here it will become +7, no? So this will become MnO2, right? Because x minus 4 is equals to 0, it will be +4. Here it will be MnO4 2 negative. Okay, here it will be MnO4 2 negative. So this is how it is converted. Now, ma'am, do I need to learn this? That's why I'm telling you, you don't need to learn each and every reaction. Simple is Fe3 positive will be oxidized to Fe2 3 positive. C2O4 oxalate will be oxidized to carbon dioxide. This to sulfur directly. Then you have NO2 negative is to NO3 negative, right? SO3 2 negative to SO4 2 negative. NO2 negative to SO3 negative, NO3 negative, right? So directly it is there, right? Now, if you talk about alkaline medium, right, neutral medium, it is directly converted to +4. Same reactions it will give here. right? In alkaline medium, it is converted to MnO4 2 negative, that is +6 oxidation state, right? What to remember here, in neutral or faintly alkaline medium, right? Same things will happen, right? Just remember that I negative is converted to IO3 negative. This is the question that they ask. I negative in acidic medium is directly converted to I2, in basic medium or alkaline medium it is converted to IO3, that is iodate ion, right? IO3 2 negative, IO3 negative, right? Other things are very simple, that it is directly oxidized, right? It will oxidize, let's say. This is a very, very important question where this MnO4 negative, it is going to convert Mn2 positive here to MnO, right? That means this is very simple, is oxidized to MnO2. Manganese salt is oxidized to MnO2. The presence of zinc sulfate or zinc oxide catalyzes the oxidation, right? This is also very important reaction. How MnO4 negative permanganate ion with Mn2 positive, they convert this to MnO2, right? These reactions can be confusing because every other time this is happening. We discussed how permanganate is converted to manganate and MnO2. See, this is the third same kind of reaction. We discussed KMnO4 is converted to K2MnO4. I'm just telling you this we have discussed. Okay, we have discussed permanganate is getting converted to manganate and MnO2. Now we are discussing that you have permanganate, that is with the reaction of Mn2 positive, it is giving you MnO2. So these three reactions are very similar to each other and hence they are very important. Easily you can do mistakes here, right? Okay, so that's why I'm writing it side by side. Now let's see the total charge. Now the question is of JEE 2023. The total change in oxidation state of manganese involved in the reaction of KMnO4 and potassium iodide. So you have KMnO4 and you have I negative. In acidic medium, we know that in acidic medium, it is directly converted to Mn2 positive and I2 here. And if you can see this here, this will be +7, this will be +2, +7 to +2. What is the change in oxidation state? That is going to be 5. So was it a difficult question? No. If you know the reactions, easily you can answer these questions, right? Not a very big deal, right? Okay. So JEE 2024, they have asked on the similar note, they have asked the question from the preparation, right? That is, you have pyrolusite ore, if you remember MnO2, in presence of base and oxidizing agent, what it will give? This is very simple. What is this? A. This is permanganate ion, KMnO4, right? Now they are saying product is neutral or acidic medium disproportionates to give B and C. Now we know that this is, they are talking about K2MnO4, that is permanganate. This is K2MnO4. Now he is saying that it is further disproportionated to B and C along with water. It is disproportionated to Mn. We know that KMnO4 plus MnO2, it is disproportionated to, right? We don't know which is B and which is C here. All we know is this is A. We can say this is A, right? Along with water. The sum of spin only magnetic moment of B and C is what? Right? Spin only magnetic moment values of B and C. So if you see, this is +7, right? And here it is, right? Here it is +4, right? Okay. So let us see, have they given any specific values here? Product A in neutral or acidic medium, okay, converted to give product B and C along with water. Sum of they are saying, okay, sum of spin only, right? If you see here, what is KMnO4? It is in +7. So if you see this here, Mn7 positive is nothing. We know that what is Mn? Mn is 4s2 3d5. So Mn7 positive is what? You take out 7 electrons from here. 7 electrons taken, it will be 3d0. Simple. It will be 3d0. Now Mn4 positive will be what? 2 electrons from here, 2 from here, it will be 3d3. Now here it will be mu is going to be 0. In this case, mu is going to be, they are saying in the nearest integer. So it will be 3.8, which is approximately equals to 4. So mu, if I say this is 1, this is 2. So mu is equals to 0 plus 4. That is 4. So nearest answer will be 4 is the correct answer here. Okay. JEE Mains 2024 question. Right. Tell me if that was easy or difficult or what. Right. Nahi Jainam, I would not advise class 11 students to watch it, right? You will get scared only. Take your own time and after that you can jump to DNF block, right? Okay. So now I think that is done and we already have our answer. Now next is potassium dichromate, right? Let's discuss the next oxidizing agent, that is potassium dichromate. They ask more questions from potassium permanganate than from potassium dichromate. Okay, potassium permanganate, they ask more questions, but you never know, the trend can easily shift, right? So let's discuss potassium dichromate. So similar way, here you will feel less questions will be there. Okay. Yes, wait a minute. Let me see. We are left with anything here, right? I think so. We have completed. Yes, we have completed everything here. Yes. Okay. So in potassium dichromate, that is K₂Cr₂O₇, how it is formed. So firstly, it is a very important chemical used in leather industry and an oxidant for preparation of many azo compounds, right? You must have seen this in organic chemistry, K₂Cr₂O₇, that is there, right? Now, it is formed from a very, very important ore, that is chromite ore. And directly questions they have asked, which of the following is chromite ore? Find the oxidation number of chromium in the chromite ore. These kind of simple questions they have asked. In JEE, yes, in JEE they have asked, right? So, FeCr₂O4, if you see this here, right, this is called the chromite ore, that is called with sodium or potassium carbonate. If you see, this is chromite ore. When it is fused with sodium or potassium carbonate, right, in the presence of an oxidizing agent, produces chromate ion, that is Cr3 positive. Okay, so if you see this here, this is wait a minute, chromate dichromate. Wait a minute, let me just show you the differences here, where it should be. I'll just show you here. Okay, there are, just like you have permanganate and manganate, similar way you have chromate and dichromate. Okay, so I'll just show you here what is chromate ion, what is dichromate ion, what is dichromate ion, what is, and they are pH sensitive, so that's why it form, like, they are very, very important for you, right? Okay, so if you see this here, chromate ion, can you predict here? That is Cr₄O4 2 negative. Dichromate is Cr₂O7 2 negative. That is the difference. Okay, understood? CrO4 negative, CrO4 negative, and this is Cr₂O7 2 negative. Now, can you give me the colors here? Can you tell me the colors? I have already written the colors here. So, if you see, this chromate ion will exist in yellow color. Yes, students, I have already written the colors here. Okay, that's why I have written this in yellow color. This I have written in orange color. Right? Chromate ion is yellow in color. Right? So you can just write it here as well. And this is orange in color. This is orange in color. Right? Okay. So just like we did from ore to manganate to permanganate, in the similar case from ore to chromate to dichromate. This is going to be our sequence. Okay. So let's understand. So you have this ore, that is chromite ore. This is chromite ore. From this chromite ore, the formula is very important, right? Chromite ore will convert it into chromate, right? This is chromate. That is the yellow solution, as I told you, right? And how it is converted? By using sodium carbonate and oxygen, it is directly converted to chromate. Now, you don't have that many preparation steps here, so relax on that. From chromate to dichromate, right? This is pH sensitive, so that's why I'm telling you here. In the acidic medium, when you put it in the acidic medium, this is converted to dichromate. Dichromate. But can you see, this actually is sodium dichromate. We need to have potassium dichromate. So we will further react this with KCl, and here you will have potassium dichromate. And here you will have potassium dichromate. Okay, that is orangish in color, as you can see here, right? So now let's see this. The solution is filtered and acidified with H2SO4 to give a solution from which orange solution sodium dichromate is formed. Now from here we crystallize it, we added KCl there to replace sodium with KCl, and you have the formation of potassium dichromate. Okay, so what we did, from chromite to chromate, chromite ore to chromate ion to dichromate with sodium dichromate, then we converted into potassium dichromate. So these are the 4 steps that we discussed here, right? Now let us see the properties, right? So now the first property is that it is pH sensitive, right? Okay. The first property is, guys, that is, it is pH sensitive, right? So if you see this here, this is CrO4 2 negative, this is Cr2O7 2 negative, and here if you see, this is interconvertible with each other, right? So let me just put that here. This I am drawing with red pen, this I am drawing with OH, blue pen. So that you can remember this, right? So when you have pH is greater than, pH is less than 7, that means it is acidic medium. That means it is acidic medium. Then you will have the conversion, then you will have the existence of Cr, then you will have the existence of Cr2O7 2 negative. That's why if you see this here, what we did, we converted chromate ion to dichromate ion in the presence of acidic. Because in acidic medium, dichromate ion will exist. In basic medium, if the pH, let's say pH is greater than 7. This is a very, very important question, guys. If pH is greater than 7, it is basic. Then in that case, you will have the existence of CrO4 2 negative. Okay, it's a very, very, very important question based on which they ask questions. Okay, this is a very important point, that it is pH sensitive. Just remember, when it is acidic, you will have dichromate, acidic dichromate, acidic dichromate, acidic dichromate. Okay, in acidic medium you have dichromate, in basic medium you will have chromate ion existence. Okay, right? That is the reason, again I am saying, in this case what you do here is, to convert chromate to dichromate, you add acidic. So if you want to convert dichromate to chromate, give it basic condition, it will be converted, right? Okay, understood? Now let's see the structures here. So both of them have tetrahedral structure. If you see chromate ion, that is yellow, it is tetrahedral, right? Simple. Then you have dichromate ion, which is CrO2 1 2 3 4 5 6 7. That is how the structure. Now this is actually tetrahedral. It is actually double tetrahedral. If you see, this part is tetrahedral, this part is tetrahedral. So that's why it is having 2 tetraheads sharing one corner with CrO-Cr bond, right? So what they can ask you, this becomes a very important structure, because they can ask you, in which of the following you have CrO-Cr bond, right? So that will be dichromate ion has CrO-Cr bond. Okay, understood? Now let's see the other properties here, right? This we have already discussed. The oxidation state of chromium in chromate and dichromate is the same, right? So if you see, this is a very, very important point that here we have discussed, chalo, that if you want to convert, this is dichromate or chromate? Chromate. Chromate in acidic conditions will be converted to dichromate. Dichromate in basic conditions will be converted to chromate, right? I think there is no need to write it here because this we have already done, right? So it is already done. So there is no need to write it again and again, right? So let's discuss this part here, right? Oxidation state, this is a very important question, that in chromate and dichromate oxidation state is same, right? Okay. So if you see this here, Cr₂O₄ negative and CrO4 negative. If you see this here, this will be 2x minus 14 is equals to minus 2. 2x is equals to 12, x is equals to plus 6, right? Can you see here also it will be plus 6. How? X minus 8 is equals to minus 2, so x is going to be plus 6, right? So oxidation state is not different in chromate and dichromate, it is completely same, right? Okay, yes. Now let's discuss very important question, that is, you have KSP values, solubility product values. Now, if you see, Na2Cr₂O7 is not used in redox titrations as primary standard, but K₂Cr₂O7 is used, right? Why this is not used? Why, if you say Na2Cr₂O7, this is not used and this is used, right? Because the solubility product of Na2Cr₂O7 is very high, so it will be highly soluble. That is the reason it will not have its own identity in the titrations, and that is the reason it is used, right? Again, a good JEE level of question. Okay, right? Okay, understood. Let's see next. Very important. We discuss about KMnO₄ heating also. It is decomposed to potassium. Potassium permanganate is decomposed to manganate and MnO₂. That we discussed. Now, so potassium dichromate is decomposed into chromate and Cr3 positive. Or you can see directly write it here, or you can just say K₂Cr₂O4, right, and Cr2O3, or you can just simply say it is decomposed to chromate in a simpler way, right? Because this is how it is difficult. Dichromate ion is directly decomposed on heating to chromate. Just like I'm just giving you so that you can remember this for your exam, just like potassium permanganate was converted to manganate and MnO₂. Here it is converted to chromate ion and Cr3 positive. And Cr4. This is the easy way of remembering this, right? This is the easy way of remembering this, right? Okay. Sunil, I can't do anything about it, right? It's their future. All I can do is teach you, right? If you want to talk to strangers, you can. If you want to utilize the knowledge, you can, right? I can't, if I start holding like each and every student that you have to do this, you have to do that, they don't deserve to get that seat, right? Okay. And I know the students who are enough dedicated, they are not even focusing on the chats, right? So that doesn't matter, right? That should not matter to you as well, right? So now, next is it has a melting point of 670 Kelvin. It is appreciably soluble in hot water, but moderately soluble in cold water, right? It is strong oxidizing. Now, in alkaline medium, in basic medium, tell me everybody, if I give here basic medium, what will happen? In basic medium, it is not directly converted to CrO4 negative. So it is not an oxidizing agent, right? So it is itself it is converted to here this chromate, which is +6, and this will also be +6. And that is the reason, because in basic medium it is converted to chromate where there is no change in oxidation state. So that's why it is not going to act as an oxidizing agent. It will only act as an oxidizing agent in the acidic medium, right? So in the acidic medium, directly, you don't have to remember this, you don't have to remember this, you don't have to remember this, any of this. Just remember Cr2O7 negative is directly converted to Cr3 positive, and it will act as oxidizing agent only in the acidic conditions, not in the basic conditions, right? Now everything else is same, just like in, but yes, in potassium permanganate, in acidic it was converting I negative to I2. In basic it was converting I negative to iodate. But here I negative is always converted to I2. You don't have to remember these electrons. This is just balancing. Just remember which is converted to which thing. S2 negative is converted to sulfur, same way. SN2 positive is converted to SN4 positive, right? Then Fe2 positive to Fe3 positive, same way, right? Then these are the, it is strong oxidizing agent in the acidic medium. These are the things which it is oxidizing. These are the compounds that it is oxidizing. This we have seen in potassium permanganate as well, that SO3 negative is converted to SO4 negative. S2O3 negative is converted to SO4 negative. SO4 negative is further oxidized to SO2. Pb2 positive is further oxidized to Pb4 positive, right? Okay. Now this is a very important. You talk about JEE mains, you talk about JEE advanced, right? This becomes a very important point, right? When I talk about JEE advanced, right? Now it is used in chromyl chloride test, right? For the detection of, for the estimation of chloride ion. How it is used, let us see. You have salt chloride, right, where you are detecting the, in a chloride ion, there will be a salt where you will have chloride ion. You want to estimate the chloride ion with the help of chromyl chloride test, right? So what you will do here, you will add potassium dichromate, and in the end what you will have is deep red vapors of chromyl chloride, that is CrO2Cl2, right? Okay, so if this is formed, that means definitely there is Cl negative ion, chloride ion present in that salt. So if you remember, we will do salt analysis as well in practical chemistry. There we will detect different ions, right? Where chloride is present, where bromide is present, iodine is present. So there you will see one test, that is chromyl chloride test. So in that, this is the reaction that happens. That's why it becomes very important, because it is there in two parts of the syllabus. One is practical chemistry. It is used in DNF block as well. So potassium dichromate is actually going to show you whether chloride as an ion is present in that salt or not. If you have chromyl chloride that has deep red vapors, if that is formed, then you can say that there is the presence of chloride ion. Further, if it is passed through this chromyl chloride, it is passed through concentrated NaOH solution. Yellow solution is observed, which confirms presence of Cl negative. This all we will study in qualitative, quantitative analysis, that is practical chemistry as well. But for now, just remember that potassium dichromate is also used in the chromyl chloride test. Okay, right? Okay, guys. Now it is used in chromyl chloride test for estimation of chloride ion. How, if this is chloride, it will be converted to chromyl chloride, that is having reddish vapors. On further passing it through a base, it will give yellow vapors. This is yellow vapors. This is red vapors. Okay, this is yellow vapors and that is red vapors that it is going to give you. Okay, yes, I know too many reactions you have here, right? Now, a reaction with H2O2, again, very important. Again, very important. Now, H2O2, if you see this here, Cr2O7 potassium dichromate is directly converted to a very beautiful color, that beautiful compound. It's like a butterfly structure. That's why this is very important, because of this particular compound here, that is CrO5, which is having deep color, deep blue color, right? And it has this kind of structure that we are going to see in, you know, based on this, they can ask you in redox reactions, we will understand this. What is the oxidation number of this Cr? It is not easily done. Okay, that we will do in redox reactions. Those who have already done redox reactions, for them, they can understand this. Double bond means this is -2, this is +2. This is -1 + 1. This is -1 + 1. This is -1 + 1. It's -1 + 1. So it is 2, 3, 4, 5, 6. So Cr is existing in +6 oxidation state here. Those who have not done redox reactions yet, this you won't be able to understand. So leave it here. Just remember that in the potassium dichromate, if it is reacted with peroxide, that is H2O2, right, it will give you CrO5 that has a butterfly-like structure. Butterfly structure. Okay, this question they can ask you, and beyond they can intermix this with the redox reactions to ask you what is the oxidation state of chromium here, right? Okay, let's see JEE Mains 2025 question here. Yes, everybody. Yes, everybody. Let's see that. Let's see that. Let's see that. If you see, considering the following reactions here, right, you have JEE Mains 2025 question, that is K₂Cr₂O₇, that is chromate, right? It is in the presence of KOH. It is giving you some A, then we add acid here, which will give you B and H2SO4 and K2SO4. So chromate ion in the base, tell me, chromate ion in the basic conditions, it will give you what? Right? Wait a minute. Wait, this was not chromate, this was potassium dichromate. Yes, this was dichromate ion. Dichromate ion in basic conditions. When pH is greater than 7, it is going to get converted to chromate ion. Do you remember? It is going to get converted to chromate ion. Now they are saying chromate ion in H2SO4. Again in acidic conditions, guys. Again, this is H2SO4. Again, pH is less than 7. That means, again, this is acidic condition. Beta, this question is based on that this is pH sensitive. Again, in acidic condition, this will again be converted to dichromate ion. Again be converted to dichromate ion. So based on the pH sensitivity, that we know that if pH is less than 7, you will have KMnO₄, I'm writing K₂Cr₂O₇. If pH is greater than 7, then you will have K₂Cr₄O₄, K₂Cr₄O₄, right? So can you see this? Based on pH sensitivity, they have asked you one question, and that too latest JEE 2025. One point, very important, pH sensitivity. I have written this for the 4th time in this particular lecture, right? Okay, so it's very, very important, right? Next is JEE 2024 question, that is, identify correct statements from below. The chromate ion is square planar. Is it square planar? No, it was tetrahedral. If you remember, chromate CrO4 2 negative, it was Cr1 2 O negative O negative. This was the structure. Okay. Dichromate are generally prepared from chromates. It is prepared from chromates. Dichromate is prepared from chromate ion. Yes, that is true. And that is prepared from chromite. The green manganate ion is diamagnetic. Green manganate ion is diamagnetic. Manganate means they are talking about MnO₄ 2 negative. And this was existing in Mn plus 6. So that was having one unpaired electron. So that is definitely that will not be diamagnetic. No, that will be paramagnetic. It has one unpaired electron, right? So this is wrong. Dark green color, K2MnO4, okay, manganate, disproportionate in a neutral or acidic medium to give permanganate. Dark green color, manganate will disproportionate in acidic medium to give permanganate. Yes, it does disproportionates into KMnO₄ plus MnO₂, right? Then acidic medium it does, right? So with increasing oxidation number of transition metal, ionic character of oxides decreases. Increasing oxidation number, if oxidation number is increasing, ionic character of the oxide should increase, right? So yes, very good. So here, yes, B is correct, D is correct, and E is correct, right? If you see increases ionic character of the oxides decreases, so answer will be B, D, and E is the correct answer here. Okay, right? This I have told you in the previous lecture, right? So let's see the next one, that is JEE 2024 question. NaCl reacts with concentrated H2SO4 and K₂Cr₂O₇. Can you see this? What is the test? What is the name of the test? Anybody in the chat box? Anybody who is listening to this class? Anybody who wants to get into like good admission in a good engineering college, right? I'm not even asking you JEE advanced question. I'm asking you JEE means question. Very important, right? NaCl that has chloride, right? It will react with K₂Cr₂O₇. That is chromyl chloride test. What is the test? Chromyl chloride. And what is formed here? CrO2, Cl2 is formed, right? Reddish fumes, okay, which reacts with NaOH to give yellowish fumes, that is C. B and C they are saying. So this is not correct. CrO2, Cl2, CrO2, Cl2, CrO2, Cl2. Now yellowish fumes is of which of the following? Is it of KHSO4, Na2Cr₂O₇, and this one? Here we discussed it that yellowish fumes will be of CrO4 2 negative, that is the chromate ion, right? So you can see this over here, right? Okay, even here, right? This, in presence of this, will give you chromate ion, that is CrO4 2 negative, which is yellow in color. That's why it is giving you yellowish fumes. Okay, so here answer is going to be CrO4. A is the correct answer. Okay, CrO4 2 negative, right? Okay, guys, understood. And we are done with KMnO₄ and K₂Cr₂O₇. And I can guarantee that if you go through whatever I have told you, you will get like all the questions will be from this lecture, right? So that you don't need to worry about. If you're doing this lecture, the 3 lectures that I am taking, first lecture, lecture 2, and especially this one, right? Then no question will be out of these lectures. Okay, that I can sure, right? Okay, now let's understand lanthanoids and actinoids, everybody. Let's understand. Let me see how many of you would like this session. I see the energy is so low. Yeah. You guys, I don't know. I think you guys watch it on recorded version or so. Will save our time, right? Is it? So, how's the energy? How's the Josh, everybody? Vasanti, Ram, Rohan, right? Rohan, it will be completed. Don't worry. That is my duty. Don't worry about that. Then Pragdesh, Ananya, Gamer, Jainam, are you here, guys, or are you sleeping in the class? Right? We are in the last part, that is F block elements, that is lanthanoids and actinoids, right? Okay. So this part, now they have started asking you questions, but there are some specific parts that they ask you questions from, right? So you need to know that from where they are asking you questions from lanthanoids and actinoids. So let's understand that part. Okay, everybody, let's understand that part. So first is lanthanoids and actinoids. In lanthanoids, you will have elements. Wait a minute. Lanthanoid, after lanthanum, right? After lanthanum, you will have the elements. And here after actinium, you will have the elements. So one by one, I'll discuss. First is talking about lanthanoids, right? So these are the elements, right, that you should remember. This lazy means lanthanum, right? You can say La, right? This Chetan means cerium, pranged means prazodinium, this is neodymium, right? Then you have PM, right? SM, samarium, EU, europium, right? G, good, that is gadolinium, right? Then terbium, disodinium, something like that it is, right? Then you have, these are not important, these are, samarium is important, terbium is important, right? Lutetium is important. Okay, so lanthanoid is very important for you. Lanthanoid, I would say, is important for you. You should remember this all together, right? So how to remember? Lazy, Chetan, pranged, Neha, playing, small excuses, good teachers daily help every tired young learner, right? Okay, do you want to remember this, or like how do you want to remember this? That's totally your choice, right? I have no control over it. I would advise you make your own mnemonic, right? Okay, those students who are lazy enough, like lazy Chetan, if you're lazy, right? So you can make your own mnemonic. If you are lazy enough, then I would advise go with this mnemonic only, right? Okay, but my advice would be make your own mnemonics related to your own life, right? Okay, now you have 14 elements over here, and the general electronic configuration here is, this is penultimate and this is anti-penultimate shell. Anti-penultimate shell. In D blocks, you have last electron in the penultimate shell. And here you have last electron in the anti-penultimate shell, that is for lanthanoids and actinoids, right? Okay, so if you see this here, lanthanoids belong to 6s, so it will be 6s2, this will be 5d021, and this will be 4f1 to 14, right? But in case of actinoids, it is going to be 7s2, 6d021, and 4f1 to, no, this will be 5f1 to 14. So this is for lanthanoids and actinoids, right? This is for lanthanoids and actinoids, the general electronic configuration. Students, based on electronic configuration, firstly, the major important part is electronic configuration for the lanthanoids. Okay, that I'll tell you, this table should be on your tips. For lanthanoids, electronic configuration is highly important. La means lanthanum, Ce cerium, Pr prazodinium, Nd neodymium, Pm promethium, Sm samarium, Eu europium, Gd gadolinium. Then you have Tb terbium, Dy dysprosium, right? Ho holium. Then you have Er erbium, not that important. Tm thulium, then not important. Yb ytterbium, very important. Lu lutetium, very important. So I'll tell you what are the very important electronic configuration. Important elements are lanthanum. Cerium is very important. Prazodinium is like okay-ish important, not that. Neodymium, surprisingly, they ask questions from this, right? Then samarium also is important. There is one property of samarium that makes it very important. Europium is highly important. Gadolinium is highly important, right? Then from here, terbium is very important. Electronic configuration, I'm saying, right? Then you have ytterbium is very important. Lutetium is very important. So these are some of the very important electronic configurations. I'll tell you how. Okay. So for that, let's understand one thing here, that these lanthanums, these lanthanoids, they exist in +3 oxidation stable, which is a stable oxidation stable. Okay. Now, because of half-filled and fully filled, because of half-filled and fully filled, some exist in Ln2 positive or Ln4 positive as well. Okay, so this is where they ask you the question, like which of the following exist, like you should know all the electronic configurations which are half filled, fully filled, or zero. That means where you have F0 or F7 or F40. These electronic configurations should be on your tips. Okay, so we will see what are these electronic configurations. Let's see that. What are these electronic configurations? If you see, okay, I'll just mark here with red pen. Okay. So if you see for 0, let me just firstly see where you have F0. For lanthanum, you have La3 positive where you have F0, which is very important. Then you have gadolinium 3 positive. That's why gadolinium 3 positive is a very important electronic configuration. Okay, gadolinium 3 positive has 4f7 half filled. Then europium, very important, it is in +2 oxidation state, it is half filled, which makes it stable, right? I think on the first page we have this only, yes. Cerium 4 positive, you must, all these that I am writing, you must have seen this repeatedly in your PYQs, okay? So cerium 4 positive is again F0, which is making it stable, right? Apart from +3, I am asking you +2, +3, +4, where you have F0, F7, F14. Those electronic configuration I am pointing here, right? I think on the first page, that's it. We only need to have this. Then talking about terbium, terbium here, if you see, terbium also in +4 oxidation state. It is 4f7, that is highly stable, right? Then if you see this here, terbium 2 positive will have fully filled, like fully filled f orbital, that is 4f14. And then you have lutetium 3 positive, which is also 4f40. So these are 1, 2, 3, 4, 5, 6, 7. 7 electronic configurations where you have F0, F7 and F14. Okay, very important. Now for cerium, you should know for lanthanum, for cerium, for europium. Now samarium electronic configuration is not important, but it's it's because of its melting point, it's important. Electronic configuration for lanthanum, cerium, europium, gadolinium, this is important. Terbium you should know, ytterbium you should know, lutetium you should know, right? Understood? These are the electronic configuration that are very, very important for you. Neodymium, they have asked it in one of the previous year questions. That's why I have written it here. Otherwise, there is no special thing about neodymium, right? But others are important. This I'll just mark here that you should do this. Okay. Lanthanum, cerium, europium, gadolinium, very important. Its electronic configuration should be on your tips. Lanthanum, right? It is stable in +3, it is stable in +4, europium is stable in +2, gadolinium is stable in +3. Then you have terbium is stable in +4, ytterbium is stable in +2, lutetium is stable in +3. All these things should be on your tips. Okay, guys, right? Okay, very, very important. This is, I don't know how much I'll tell you, this is that important, right? Now, based on this, they ask you the questions like, see, let's see. Okay? Because lanthanum closely resembles lanthanoids, it is usually included in any of the discussion of lanthanoids for which. Now, lanthanum is not basically just remember that lanthanum is actually belonging to group number 3. All the lanthanoids, this also you should know, all the lanthanoids, they belongs to group number 3. But lanthanum is actually a part of, this is actually a part of D block. This is actually a part of D block. This is not, lanthanum is not a part of F block. Why it is written under F block? Why it is studied under F block? Because the properties are similar. And the second thing is, because if you see this here, like, okay, let me just show you why it is not included. If you can see this here, can you see in lanthanum, there is no F, there is F0, no F is there. There is not even in its, like non-ionic form, in its neutral state also, it does not have F1. There is no F orbital here. That's why it is not in F block, right? It is a D block element which is included because the series goes like lanthanoid series. It is usually included in any discussion of lanthanoids for which general symbol Ln is often used. Similarly, a discussion of the alkanoids includes actinium, but actinium also belongs to D block, right? Okay. Apart from lanthanoid, if you see this, I'm again repeating this. The 14 elements are from cerium to lutetium. Lanthanum is not a part of lanthanoid series, but it is still included, right? We discuss it, but it is not actually in F block, right? Okay. Then one thing is based on atomic radius, right? Let's see one exception here. There are some exceptions here. So atomic radius, if you see from cerium, or you can say from lanthanum also, because we discussed it. Lanthanum to lutetium, actually what happens, size is actually decreasing. Now I'll tell you why size is decreasing. Now if you see here, electrons are being added and protons are added. Because protons are added here, so Z effective is increasing. You can say protons are, if added, one proton is being added here, atomic number is increasing, so Z is increasing, right? But here there is a concept called lanthanoid contraction, in which what happens, this is nucleus, these are the electrons, right? These are the electrons. Now outermost electron is there, and in between you have inner core electrons. Now here we know that inner core electrons also have 4f orbitals. Let's say here you have 4f orbitals. Now what is the work of inner core electrons? To protect the outermost electron being attracted by the nucleus, because this is positive, this is negative. If the inner core electrons do not have very good shielding effect, right? They are not able to protect the electron, then this electron will be attracted towards the nucleus, right? What is the duty of these inner core electrons? To protect the outermost electron from the nucleus, but they are not doing their duty properly, right? So shielding effect of F then P is very less, right? F, P, D, no, S, P, D, F, no? S, then P, then D, then F. It is having a very poor shielding effect. Because of its so poor shielding effect, it is not able to save this electron from this nucleus. Inner core electrons are bodyguard. If bodyguard is not able to protect the celebrity, then the celebrity will be gone, right? So similar thing. This is electron, this is inner core nucleus. 4f does not have a good shielding effect, very poor shielding effect. That's why electrons being attracted here, right? So that is called lanthanoid contraction. Size decreases, right? So what is happening here? On going from lanthanum to lutetium, Z, see, number of protons are increasing, but lanthanoid contraction is also increasing, right? Lanthanoid contraction is also increasing. That's why size will here decrease. Size will decrease here, right? But there is one exception, right, that you should know. That exception is europium, right? It has maximum size, right? They can ask you, see, europium is in between, right? If you see this, europium is in between here. It should not have the maximum size, but it has the maximum size. So what exactly happens here, right? It goes like this, it goes like this. It should be decreasing, 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 decreasing. It increases to europium, then again it is decreasing. So this is europium, right? Okay, this is europium, right? That is why this exception becomes very important, right? Then ionic radius, it is same, no exception, no exception. Okay, it is always decreasing from lanthanum to lutetium. It is always decreasing only. There is no exception in the ionic radius, right? It is always decreasing. This is the graph, decreasing, decreasing. That's it. That's all you have to do, right? Okay, simple. Not that much in detail you have, right? Just see what I'm teaching you, right? In lanthanoids, lanthanum to lutetium compounds are now. This is very important. Let's see. Oxidation states we are going to discuss, and electronic configuration are going to help us here, right? In the lanthanoids, La2 positive and Ln3 positive, compounds are predominant species, right? Firstly, Ln3 positive. Occasionally, +2 and +4 ions in the solution are also shown because of this table. I told you, like you have ytterbium 2 positive, you have terbium 4 positive, you have cerium 4 positive, you have europium 2 positive. So why they show positive, 2 positive and 4 positive? Because of their stable half-filled and fully filled electronic configuration, right? The irregularity arises mainly from extra stability of half-filled and fully filled, right? Now, because of this, they show some oxidizing and reducing nature. Let's see, very, very important, right? So if you see cerium, that exists in +4 oxidation state. Now, why it exists in +4 oxidation state, guys? Let us see and go through this here, right? If you see cerium here, where is cerium? Yeah, this is cerium. Cerium in +4 oxidation is F0. It is a stable configuration. Now, see this thing here, right? What I'll do here, let me see if we have one more page we need, right? To make you understand that. Okay? Wait a minute, I'll just teach you my way, like how I teach, right? Instead of bookish language, right? So see, what we have is, we know that cerium 4 positive exists. The natural oxidation state for lanthanoids is not +4, it is +3. For lanthanoids, the natural state is +3. So even if it is more stable in +4, like if you're more happy outside your house, even then you will have to come back to your house, right? So even if it is more stable in +4, because all of its family members are existing in +3, it will have to come back to +3, right? All the people who are staying outside abroad, right? Even if they are more happy abroad, because their family is there in India, they'll come back to India, right? At least visit them in India. Similarly here, even if it is more stable in +4, it will come back to +3. It will try, because all of the family members are there in +3 oxidation state, and that is the reason there is decrease in oxidation number. So it will itself want to get reduced, and that's why it is acting as a good oxidizing agent, right? It itself want to get reduced, and it is acting as a good oxidizing agent. So itself it is getting reduced. Similarly, you have europium, right? Europium is +2, and it wants to be in the stable electronic configuration of all the family members, that is +3. No doubt it is more stable in +2, but it would want to match with the family members. So that's why it will increase the oxidation number. So it will itself get oxidized, and that's why it is a good reducing agent. It will reduce someone, so that's why it is a very common question that is asked, why cerium 4 positive is oxidizing agent and europium 2 positive is reducing agent, right? Okay, same thing is written here, right? Okay, only in oxide. So this is some of the examples, like these are the elements. Now this also, all these elements are also very important. They exist in +4 oxidation state, but only in oxides, right? Like you have praseodymium that exists in +4, right? Neodymium +4, terbium also +4. That's very simple. Disodymium. What was the name? Yeah, name are so weird, na here. Disoprosium. Prosium. Right? So disoprosium also exists in +4 oxidation state. That's why these oxidation states, these electronic configurations are also important for you, right? Okay, so most probably they will ask you question from electronic configurations from here, right? Most probably that will be the question, right? This I have already told you, right? Then next is europium. Also we have discussed that why it is a strong reducing agent, right? Now ytterbium exists in +4 oxidation state, +2 oxidation state, right? So in +2 oxidation state, it is fully stable with 4F14. So that's why it would want to be in ytterbium 3 positive. That's why it itself will increase the oxidation number. That's why it is a very good reducing agent, because itself it wants to get oxidized. It will reduce something. So it will act as a very good reducing agent, right? Okay. Let's see some JEE questions. JEE 2024 question based, mostly you will see from lanthanoids, they have asked you questions from electronic configurations, right? So which of the following ions is the strongest oxidizing agent, which would want to get reduced, which would want to decrease oxidation number? See, why would it want to decrease? It would want to increase oxidation number and get converted to europium 3 positive. This would want to decrease the oxidation number because all the lanthanoids want to, whether they are more stable in +2 or +4, they want to be in a +3 oxidation state, because that is the stable configuration of lanthanoids, right? So answer will be C is the correct answer. Very simple question asked in your JEE 2025, is it? I think 24 it was asked, okay? Yes. Now, next is some properties. See, these properties are, let me tell you what you should learn from here. Go through this once, right? Mostly from electronic configuration they will ask, but go through this. All the lanthanoids are silvery white soft metals and tarnish rapidly near. The hardness increases with increasing atomic number. Now, this is important. Samarium being steel hard. Samarium is very hard, right? But samarium melts at 1623 Kelvin. The melting point ranges between 1000 to 1200. Samarium is extremely hard and it has maximum melting point. Maximum melting point. That is the exception of samarium, and it is very hard. And this exception they can ask you directly in the exam, right? Okay. Then they have typical metallic structure and are good conductor of heat, electricity. Density and other property change smoothly for europium and ytterbium, and occasionally for samarium and this was TM. What was the name? Yeah, the names are very weird. Name was the thulium. Okay, sure. I think that's it. And what else we have here? This is done. Now this also we are left with. I think these are some general characteristics that we are learning here, right? Many trivalent lanthanoids are colored, but both solid state and aqueous solution due to presence of F electrons. Just like you have DD transition, you have F transition. Neither this or this ion shows any color, but rest do so. Lanthanum 3 positive and lutetium 3 positive will not have any color, right? Absorption bands are narrow because, see, why they don't have? Because they have, this is F0 and this is F14, okay? Now, if you see, ma'am, europium 2 positive, it will also be colorless only. Europium 2 positive, cerium 4 positive, they are colorless, okay? They are colorless. Just remember that if you have F0 and F14, that will be colorless. Okay. Now, let's see. Absorption bands are narrow because of excitation within F level, right? The lanthanoids ion other than F0 type and F14 type all are paramagnetic, right? That is the difference, right, everybody? Other than F0 type, you have samarium 4 positive, you have ytterbium 2 positive. Europium 2 positive will have 4F7 now, then it will have color, right? So based on that simple thing only, lanthanoids are around 600 kilojoule, IE2 about this much, and comparable with those with calcium. Now this is also important that their ionization enthalpies are comparable with calcium. Lanthanum, gadolinium, and lutetium have abnormally low IE3 due to stable +3 configuration. We know that lanthanum, these are the three which are stable in +3, like because of their F0, F7 and F14 configuration, they are stable in +3. That's why they have very low IE3, right? To take out one electron, then two, then third electron, it's very easy because they are existing in 0, 7 or 14 electrons, right? So that's why it is very low, right? In their chemical behavior, the earlier members of the series are quite reactive, similar to calcium. Their properties are matching with calcium, but With increasing atomic number, they behave more like aluminium. This is an important point. This is an important point. They have also asked question based on this. In their chemical behavior, their earlier member of series are quite reactive, right? Similar to calcium, but increasing atomic number, they behave more like aluminium, right? Okay. Now the general reactivity, if you see, they combine with hydrogen when gently heated in the gas, right? The carbides, if you see different are formed when metals are heated with carbon. Their oxides and hydroxides, alkaline earth metal, and these are also formed. So a simple chart I'll show you here, right? That is this chart. Okay, so when it is heated with sulfur, it is formed sulfide. Okay, heated with oxygen, it will form oxide. Heated with acid, it will form hydrogen. With halogen, it will form uh, halides. With water, it can form hydroxides. With carbon, it can form carbides. With nitrogen, it can form nitride. If you see, in all these cases, Ln we have taken as 3 positive. It's not a big deal. If you want to see this, it is Ln 3 positive and S2 negative. Ln cross multiply and you will have this formula. If you see with the, let's say nitrogen is 3 negative, so it will be Ln N. If you say, ma'am, let's say with carbon, it is 4 positive. So that's why this is, wait a minute, 9. With carbon, it's not actually forming it like that. It is forming with +2, right? Ln2 positive is forming it, right? Others, it is 3 positive only that is forming. Okay, like you have Ln3 positive, this is O2 negative, that will be Ln2O3. Okay, so till now, so they don't ask questions from these reactions. That's why I'm not giving that much importance to these reactions here, right? Okay, let's see here. They liberate hydrogen with dilute acid and burn. In halogens form halides. They form oxides also. They form hydroxides also, right? Okay, the hydroxides are definite compound, not just hydrated oxides. Acha, now tell me one thing. One question that they ask here is, wait a minute, that question is on the basicity here, right? Okay, which is more basic? Which is more basic? Now, if you see this here, size from lanthanum to lutetium is decreasing, right? So here size is large, here size is less, size of lutetium is less. That's why it is easy to break the bond. Here bond length will be more, here bond length will be less. Size is less, bond length will be less, so it is difficult to break this bond. That's why lanthanum hydroxide is more basic as compared to lutetium. Okay? Yes, everybody? Chal. I think that's it. Now let's see JEE 2023 question. Just 5 minutes more. Right? The pair of lanthanoids in which both elements have high third ionization enthalpy. Right? Third ionization enthalpy will be high in gadolinium. Wait a minute, in which both elements, right? It is, no. Is it even the right question? Are the options even right? Because gadolinium is with lutetium, I think it should be Lu. Okay? I think it should be. The pair of lanthanides, both elements have high. It's a high they are saying. It's a both. I'm so sorry, guys. Brain is shutting down, I think. High they are saying. I thought low. Low ionization enthalpies for lutetium, gadolinium, and lanthanum. Because they all are stable in +3 oxidation state. If you see lanthanum, this is lutetium. It has 4F0, it has 4F7, it has 4F14. That's why they are stable in +3 oxidation state. So this is stable, this is stable, this is going to have low, this is going to have low. But this both are going to have high, so answer will be C. Okay? Both will have high, so answer will be C. Right? Okay, so last thing, that is actinoids, right? Not that much about actinoids you have in your syllabus, but still I'll tell you some important points of actinoids. See, they are radioactive elements, so their electronic configuration is very difficult to learn, and they will not ask you that, right? So some important points you have to learn here, right? This is the series of actinoids that you should remember by this. Thin Panda uses new pastries. Amit Cool brother carries extra fruit mix, methi dosa, naan, and lemon rice. Okay, so this is Thin Panda uses new pastries. Amit Cool brother carries extra fruit mix, methi dosa, naan, and lemon rice. Okay, okay, that's how it is done. Now, after remembering, see, this is your part. You can only remember. I can't force you to remember this, right? So you have to do practice here. Now I'll tell you all these you don't have to remember, okay? Just remember some important. Like you have thorium here. Now thorium in +4 oxidation state is 5F0, okay? And then if you see curium, that is Cm, it is in +3 oxidation state. It is stable. Okay, it is 5F7, right? Till now they have not asked it. Okay, till now they have not asked from actinoids. They are asking from lanthanoids. But my idea is they can also ask from thorium, curium, right? And let me just see what are the others, right? +3 and +4. Now we have these two which are stable. See, actinium is obviously stable in +3, right? Then what you have next is, then here you have berkelium. So very rare chances they will ask you this, but you should, point it out. Very rare chances they will ask you from actinoids. Very, very rare chances. Lawrencium, you should know that, okay, it is stable in +3 oxidation state. And I think that is more than enough. You don't have to do more, right? More than enough. Even if you do this maximum, it's okay. More than that, you don't need to do, right? So next is, now here ionic radiation, everything is gradual decrease in size of this across the series. This may be referred to as actinoid contraction. Now, actinoid contraction and lanthanoid contraction, which is more? Actinoid contraction is due to 5F and lanthanoid is due to 4F, right? Both have poor shielding effect, but 5F is even poor, even poor. So you can just write it like this. You can write it like this. 5F has even poor shielding effect as compared to 4F. Shielding in 5F is so poor that more decrement in the size is observed in lanthanoids, right? So the contraction is, however, greater from element to element in this series, resulting in poor shielding effect of 5F electrons. 5F is having even more poor shielding effect. There is greater range of oxidation states, right, that you will see here. Very weird thing that you will see here is, this they can ask you, which of the following oxidation state is maximum for actinoids? So for actinoids, you don't have to remember everything. Just remember maximum oxidation state is +7. Just remember this, okay? Maximum oxidation state is +7. That's it. That's all what you have to remember, right? Okay. Why it is so? Because the difference in 7S, 6D, and 5S is very less. The difference in energies is very less. That is the reason here they have variable oxidation state and it is going up to +7, right? For lanthanoid, it was not going up to +7. For actinoids, it is going up to. These are some of the properties. They are highly reactive. They are radioactive. The action of boiling water on gives mixture of oxide, hydride. Combination with most non-metal takes place in moderate temperature. Hydrochloric acid attacks all metals, but most of slightly affected by nitric acid, owing to the formation of protective oxide layer. Alkalis have no action. So this is an important point, that HCl attacks all metals of actinoids, but most are slightly affected by nitric acid, owing to the formation of protective oxide layer. alkalis have no effect, right? Alkalis have no action on these actinoids, but hydrochloric acid can attack, and that too, nitric acid will not be able to attack. Okay, so ionization enthalpy of actinoids are lower than that for early lanthanoids. What is exactly, that is not known to you because they are radioactive elements. It's very difficult to study them, right? 5f electrons are more effectively shielded from the nuclear charge than 4f electrons. Basically, we want to say is that 5f electrons, na, if you see this, we are saying that actinoids are lower than earlier lanthanoids. Their ionization enthalpy is even lower. It is easy to take out electrons from them. Why? Because 5f electrons are more effectively shielded, because we want to take out electron from 5f. Their shielding effect is poor, but they are more effectively shielded. They are not good shielding. They don't possess good shielding effect, but if someone shields them, that is good, right? They possess good shielding effect, like themselves, they are good, not good in protecting someone, but someone is protecting them good, right? It's like that, right? So I think that's it. Uses of lanthanoids, production of alloys, steels for plates and pipes. Well-known alloy is, now this is important. This is important. This is important, guys, from your NCERT. A well-known alloy is mish metal, which consists, very important, which consists of lanthanoid metal 95%, iron 5%, and traces of sulfur, carbon, calcium, aluminium. This point is important for you, right? This is mentioned in the last page of your NCERT, right? So all these are uses in your NCERT. A good deal of mish metal is used in magnesium-based alloy to produce bullets, shell, light flints. Mixed oxides of lanthanoids are employed as catalyst in the petroleum cracking. Some individual lanthanoids oxides are used as phosphors in television screens. That means the glow in the screen that you see, right? And similar fluorescent surfaces, right? Okay, that's it. Now, last part that I have told you, right? This PDF will be provided to you, right? Okay. Thank you, Abhijit. Thank you so much for encouraging me, right? So sweet. So guys, I think that's it for today, and this chapter is done and dusted. We have completed this chapter, DNF block, and next class I'm going to start with coordination compounds, right? And I would want all of you to attend the coordination compounds as well, right? Inter-village vlog, you should have attended the class before. It's been 2 hours. I have already completed all of that, right? So this is first homework, preparation of potassium permanganate from MnO₂ involves 2 steps. Yes, that is the homework. First step in the reaction with KOH and this to produce which of the following? That is the first question. That is JEE 2025 question. First. Second is the electronic configuration of Einsteinium, that is atomic number 99 is what? That is JEE 2024 question here, right? Okay, everybody, got it? Yes. Okay. Abhijit, focus on class 11th for now, right? Okay, yes. Okay then guys, that's it for today, and this is our official Telegram channel where you can see all the important information for your JEE, and I would love to see your comments in the description, in the comment section regarding if you're doing your homework or not. And guys, if you see this here, for all the 12th and all the droppers out there, right, for your JEE 2027, 2026 preparation, we have Sigma batch for you, which is at 4999, which is available at this point, where you will have live classes, right? You will have live classes, mock tests are going on, right? And quizzes, leaderboards are there in the class, test series are provided to you, modules are provided to you. So everything that you need for your JEE 2026 preparation, which is very near, right? We have very less time for the preparation, right? So even now you have time, even now you can enroll and get yourself on track, right? So everything, all the details are there over here. You have at 4999, right? You have the basic thing, that all the things that I told you, right? Everything is there at 4999. But if you want those Tattva modules in soft copy version in PDF, that will be provided here. If you want the hard copies of that, and you want these kind of QR cards for your revisions, right? That will be provided at 9999. And here I'll just show you this booklet you will get for chemistry, similarly for mathematics formulas and physics, right? So it's like a short notes that we will provide you, because right now you don't have time to make short notes, right? Right now you should practice. For practice, we are providing you modules. You should start giving mock tests, so that's why mock tests are there. You should not waste your time in making notes and short notes. At this point, I would not recommend that. For that, teachers' notes will be provided to you, and you should do quality questions, right? That is the reason in these modules and DPPs, only quality questions will be there. Okay? Yes? Okay then, guys, that's it. Then, wait a minute. Okay? Now, I'll be waiting for your homework in the comment section. Let's see how many of you do that, right? Okay? Okay then, guys. Bye-bye. Take care. See you all in the next class. Bye-bye.